Trigonometry. Now today we're talking about trigonometry. So talking about trigonometry, let's check out what we have on the board. Now trigonometry is the branch of mathematics dealing with the relations of the sides and angles of a triangle. So when we talk about trigonometry, we're going to be revolving a lot around triangles. Now, so this trigonometry, they deal with relations of sides and angles of a triangle. So if we're having, just like here, we have what? A triangle. Now, this triangle here, we have what? Here to be our internal angle, which is theta. Now, the angle facing here, this place is our opposite. We're going to talk about this in detail. Now, the longest side here is your hypothesis, and this side here is your adjacent. So, having this, so we have to move forward. Now, pay close attention to this. A right angle triangle what is considered here. So considering a right angle triangle with what side x, y, z. Now the longest side, which is what x, z, is known as your hypotenuse. As your hypotenuse. Now we have what side x, y. Side x, y here is your adjacent. And we also have y, z. So your y, z here is your opposite. Now I would like to bring to your notice, the positioning of your opposite is relative. It's relative to what? The internal angle given. So if I have my internal angle here to be phi, then conversely, this particular place becomes your what? Your opposite. So what am I trying to say? Your opposite is what? Relative. It is relative to what? To the internal angle given. The opposite is relative, or rather the positioning of the opposite. The position of opposite is relative to the position of the internal angle. So where your internal angle is facing, that particular place becomes your opposite. Basic trig ratio. So basic trig ratio, we have what? Three basic trigonometric ratios, which is what? The sine, and your sine is given by, now we can denote them using SOHCAHTOA. Now your sine, which is what? Given as what? Your opposite over your hypotenuse. Don't forget, your hypotenuse is the what? Longest side. The next one here is your what? Your cosine, which is also known as cos, given by the adjacent over the hypotenuse. And finally, we have the what? Tangent. We have the tangent, which is given by the what? The opposite all over what? Adjacent. So the short form to represent all this is this, which is what we call the SOHCAHTOA. Talking about trigonometry ratio, trig ratio. So let's do that very fast. So the first one here is the sine. Sine is equal to opposite 7 over hypotenuse. Okay, cos is equal to adjacent over hypotenuse. Tan is equal to 12, which is what? Opposite over adjacent. Now, going further, these trigonometric identities, they have their inverse. Now, their inverse here, let's start with sine. So, inverse here, which is what? Your cosec. Cosec is equal to 1 over sine, and that is equal to y over z. It's inverse. While what? Your sec is equal to what? 1 over cos. 1 over cos, and that is equal to y over x. And finally, we have our what? Cot, which is equal to 1 over tan, which is now equal to z over y. So these are what our major trig ratios and their various inverse. Let's talk about special angles. Now, special angles. So let's consider an equilateral triangle with all its sides to be 60 degrees. Now, all its angle to be 60 what? Degrees, and all its what? Sides to be what? Equal. And so this is what? An equilateral triangle. So let's say this equilateral triangle was now what? Bisect. So after bisecting, this is what we're going to have. We're now going to have what? 30 degrees here. I have 60 degrees here. I'll have here as 2. Here is now 1, 1. I'll now have here as 1. So we have to find what? This other side. So to find this other side, we're going to find it by using Pythagoras, which says your hypotenuse squared is equal to opposite square plus adjacent squared. This is your formula for Pythagoras. Now here, your h here, which is 2. 2 squared is equal to opposite square plus the adjacent, which is what? 1. So 2 squared, that's what? 4 is equal to o squared plus what? Plus 1. Collecting that, that's 4 minus 1 is equal to o squared. So o here is equal to what? Square root of 3. So this part here is now as what? Square root of what? 3. Now let's go further. So I told you that what? Where this thing is facing determines. So in this diagram, we're going to start with what? 30 degrees. So here is what? Root 3. Here is 2. Here is 1. So if I say sine, don't forget, this place is now your opposite. This is your hypotenuse, and this is your what? Adjacent. So if I say sine 30, sine 30, don't, sine is equal to what? Sine is equal to opposite over what? Hypotenuse. So sine 30 is equal to what? Is equal to what? 1 over 2. So I would like us to fill this table. 1 over 2. Okay, so going forward, we have what? We have sine 30. So let's find what? Cos 30. Cos 30 here is equals adjacent over what? That is what? Root 3 over 2. Which is what? Root 3 over 2. And finally, cos 30 is equal to what? Root 3 over 2. And finally, tan 30 is equal, don't forget your tan. Your tan is what? Opposite 1 over what? Adjacent, root 3. At this junction, we cannot leave this like this, so we want to rationalize. Root 3 over root 3. 1 times root 3, that's equal to what? root 3 over root 3 times root 3, that's what? Root 9. So that's what? Root 3 over 3. So our tan 30 is going to give us the value of root 3 over 3. Now, so since we've done for 30 degrees, let's proceed. Let's proceed to what? To 60 degrees. So, proceed to 60, we now have what? A new diagram. Here is now what? 60 degrees. Then this is 2, this is 1, and this is what? Root 3. So at this junction, we can now say that sine 60 here, sine 60 is equal to root 3 over 2. Sine 60 here is what? Root 3 over 2. So continuing, cos 60 here is equal to 1 over 1 over what? 2. 1 over 2. Pay close attention, then find your what? Tan 60. Tan 60, that which is going to give us is going to give us what? Root 3 over 1, that is equal to root 3. Now, having done this, we've been able to what? From what? An equilateral triangle, we've been able to what? Draw out these angles, and we've treated what? The special angles individually. Now let us go to the what? The special angle of what? 45 what? Degrees. So moving to 45 degrees. Now pay attention, this is a square, and all the whole side of a square is what? 90 degrees. So I'm bisecting the 90 degrees. Now here is now what? 45 what? Degrees. Here is now 45 degrees. So I can now bring out this diagram out. This is what I'm going to have. I have here as 45 degrees. I also have here as 45 degrees. I have here as 1. I also have here as 1. So using Pythagoras to find what? The hypotenuse, it becomes what? H square is equal to O square plus A square. So my H square is now equal to this is what? 1 square plus 1 square. That's my H square is equal to what? 1 plus 1. So H is equal to what? Square root of 2. So this is what? Square root of 2. So let us now find what? Let's now find sine. Sine 45 is equal to, let's say using here, sine 1 is equal to what? 1 over what? Root 2. Rationalize, that is what? Root 2 over root 2. So that's now what? Root what? 2 over root what? 2 square. Here this cancels. That's equal to root 2 over 2. So what? Cos 45 equal to what? Root 2 over 2. So that is that. We proceed. Cos 45. Cos 45 is equal to what? 1 over what? Root 2. Rationalize again. That's root 2 over root 2. That is equal to what? Root 2 over 2. So we got root 2 over 2. Then lastly, go to what? Tan 45. Tan 45. Tan 45 says that 1, 1. 1, 1. That is what? Opposite over 1 hypotenuse, which gives 1 divided by 1, which is equal to 1. No, so at this junction, we've been able to what? Get our special angles. So let us now use these special angles to answer questions. So going further, we have a question here. So we want to use what? Special angles to treat this question. question. So this is now what? 1 plus tan 60. What is tan 60? Root 3 times what? Tan 30. Tan 30 is what? Root 3 over 3. Divided by what? What is tan 60? Tan 60 is equal to what? Root 3 plus what? Tan 30 is equal to what? Root 3 over 3. So at this junction, this is now 1 plus root 3 times root 3, that's what? Root 3 square. Root 3 square over 3. All over this two. Look up your LCM. Your LCM here, 3 divided by 3, 1. So 3 divided by 1, 3 times this, that's what? 3 root 3 plus what? 3 divided by 3, 1. 1 times root 3, that is what? Root 3. Now, this cannot cancel this. 3 divided by 3, that's what? 1. 1 plus 1 divided by what? Root 3. 3 root 3 plus what? Root 3, that is what? 4 root 3 divided by 3. So, we cannot proceed. This is now what? 2 divided by 4 root 3 over 3. That's what? 2 times what? 3 over 4 root 3. 3 times this, that's what? 6 over what? 4 root 3. So rationalize root 3 over what? Root 3. 6 times root 3, that is equal to what? 6 root 3 over 4 times root 3 times 3, that's what? 3. So what are we having? 6 root 3 over what? Over 12. 2 here 1, 2 here 2. That is equal to what? Root 3 over 2. So root 3 over 2 there is your what? Your final answer. So express what? 1 plus cos 30. 1 plus what? Cos 30 here is root 3 over 2. Root 3 over 2 over 1 minus sine 30. Sine 30 is what? 1 over 2. Looking for LCM, this is now what? 2. 2 divided by 1, 2, 2 times 1, 2 plus 2 divided by 2, 1, 1 times root 3, root 3, all over what? The LCM here is what? 2 divided by 1, 2, 2 times 1, 2 minus 2 divided by 2, 1, 1 times 1, 1. So this is now what? 2 plus what? Root 3 over 2 divided by 2 minus 1, 1 over 2. So that's what? 2 plus root 3 over 2 times what? 2 over 1. This cancels this. And this is now equal to 2 plus what? Root 3. And 2 plus root 3 is the final answer. So we have what? The question here to evaluate. Now this is what? 1 minus sine 45. Sine 45 is what? Root 2 over 2 over 1 plus cos 30. Cos 30 here is equal to what? Root 3 over 2. So at this junction, look for LCM. LCM here is what? 2. 2 divided by 1. 2 times 1. 2 minus what? Root 2. 2 divided by 2, 1 times this. Divided by what? This here, that's what? 2 plus what? Root 3 over 2. This LCM. 2 divided by 1, 2. 2 divided by what? 1, 2. 2 times 1, 2. Plus 2 divided by 2, 1. 1 times root 3. So at this junction, 2 minus root 3. 2 minus root 2 over 2 divided by 2 plus what? Root 3 over 2. That's 2 minus root 2 over 2 times what? 2 over 2 plus what? Root 3. Here 2 cancels 2. So this becomes 2 minus what? Root 3 over 2 plus root 3. So at this junction, we'll continue by what? Conjugate. conjugate. So this becomes what? 2 minus what? Root 3 over what? 2 plus root 4. 2 plus what? Root 3 times what? 2 minus what? Root 3 over what? 2 minus root 3. So, okay. So 2 times 2 here will give us what? 4. 2 times 2 here will give us what? 4. 2 times this will give us minus 2 root what? 3. This times this will give us what? Minus 2 root what? 2. Minus times minus will give plus. 6 times 3. 2 times 3, which is what? 6 over what? 2 times 2, 4 minus root 3 times root 3. That's what? Root 3 square. So proceeding, can we add? We cannot add. So 4 minus what? 4 minus 2 root what? 3 minus what? 2 root what? 3 plus what? Plus 16 all over what? 4 minus what? This cancels 4 minus 3, that's what? 1. That is now equal to what? 4 minus 2 root 3 minus what? Minus what? 2 root what? 2 root 2 plus 16. Okay, so 16 plus what? 16 plus 4. 16 plus 4 that's what? 20. And at this junction, can leave this in here as our final answer. So I proceed. So I said it's our final answer. But please, this is the final answer. 4 minus what? 2 root 3 minus 2 root what? 2 plus what? Root 6. So this is our what? Final answer. You cannot add these two because they have two different bases. You cannot add these two because they are also of what? Different variables. So still on it. So without using mathematical tables or calculator, evaluating your answer in sorts. That was sine 45. So sine 45 here is what? Root 2 over 2 plus what? Cos 60. Cos 60 is what? 1 over 2 divided by tan 30. Your tan 30 here is equal to root 3 over 3. So look for LCM, which is 2. 2 divided by 2 and 1 times root 2. Root 2 plus 2 divided by 2 and 1 times 1. Now divided by what? Root 3 over what? 3. So this is root 2 plus 1 over what? 2 times 3 over root 3. This is now equals 3 times this, that's what? 3 root 2 plus 3 times 1, that's what? 3. All over 2 times this, that's what? 2 root 3. So being 2 root 3 there, you have to what? Rationalize. So rationalizing, it becomes 3 root 2 plus root 3 over what? 2 root 3 times what? Root 3 over root 3. This is now 3 root 6 plus what? 3 root 3 over what? 2 root 3 square. Where this cancels, this is now what? 3 root 6 plus what? 3 root 3 over what? 6. So I can now bring up factorize my 3. That's 3 open bracket root 6 plus root 3 all over what? 6. 3 here 1, 3 here 2. Your final answer is now what? Root what? 6 plus root 3 over 2. So this becomes your final answer. I believe you are following. So we're asked to take what? Pay attention to what? This exercise. So in this exercise we have what? Question. And this is the what? The answer. And we have also another exercise, and this is the answer. So try as much as you can to practice them, which is best for you. Now we're talking about quadrants and ratio of angles between 0 degrees and 360 degrees. Now let's see, this is our quadrant. Now for this quadrant here is from, this is the first quadrant, is from 0 to 90 degrees. This one here is from what? 90 to 180 degrees. Then from 180 degrees to 270. And this for 270 degrees to 360 degrees. Now, this being a quadrant, our first quadrant we have what? All as positive. When I say all as positive, that means what? Sine is positive in your first quadrant. That is from 0 to 90. Every number under sine is positive. Cos is positive and tan is positive. But in your second quadrant, only sine is positive. Only sine is positive. So sine here is positive, cos here is negative, tan here is negative. Now, in your third quadrant, this is your first quadrant, call your first quadrant, call your second quadrant. Now your third quadrant, only your tan is positive. Your tan is positive, your sine is negative, your cos is negative. And finally, your fourth quadrant is from 270 degrees to 360 degrees. Your cos is positive. So only your C is positive, your sine is negative, your tan is negative. So if we are given a sine, if we are given what? A negative, if we are given a negative ratio, the negative ratio will either fall between 270 to 360, or let's say we are given a negative value for a cos, for a sine. That negative value for a sine will either fall in the third or fourth quadrant, because in the first and second quadrant, every value for cos or for sine is positive. Now let me explain this thing. Let's say we are given a number above 90. Pay attention. We are given a number above what? 90. Now, 91 is in the what? Second quadrant. And you are looking for what? Sine of what? Sine of 91. Sine of 91 is in this place, and sine is said to be positive in the second quadrant and also in the first quadrant. Now, if you are looking for sine 182, it's going to be negative because it has exceeded its own territory. It has to do with territory here. It has exceeded its own territory into the third quadrant, and in the third quadrant, your sine is negative. Okay, so proceeding to the fourth quadrant, which is only cos, is positive. Only your cos is positive. Only your cos is positive in the fourth quadrant. Now, there are acronyms to represent this. There are acronyms to represent this. Now, look at, you can start from here. C-A-T-S. C-A-S-T, that's what? Cast. You can use cast to represent your quadrant. That for you start from the fourth quadrant, C-A-S-T. Like I used to represent it, this means that what? Your fourth quadrant, cos is positive. First quadrant, all is positive. Second quadrant, sine is positive. Third quadrant, tan is positive. If you don't represent like this, if you don't represent it using C-A-S-T, you can use what? A-C-T-S, acts. So whichever you want, so far you are able to represent it in the way you understand. But if you are going like this is what? Anti-clockwise. Sorry, this is in its clockwise direction. As you're going to take what? A-C-T-S as what? Acts, which is a all, cos, tan, sine. So with this, we'll be able to explain our quadrant. So let's pick one or two questions from them and evaluate. I'd like us to know the following relations. Now, this is cos in your first quadrant. Know your cos in your fourth quadrant is going to give you what? 360 minus theta, which is give you your cos in your fourth quadrant. Sine theta, know your this in your second quadrant is going to be 180 minus theta, and this is tan. So know your tan in your when your tan falls in your third quadrant, or rather when the value falls in your third quadrant. To find the value of tan in your fourth quadrant, which is equal to tan in your 90 degrees, is going to require what? Theta minus what? 180. So please, I would like us to what? Note this, because we are going to use it a lot when we are giving angles above 90 degrees. So I want to use what? This relation to determine how to bring them back from what? From angle above, or relations above 90 degrees, bringing them back to 90 degrees. You need this relation. So when let's pick examples to explain them. Now, look at this question. Solution. The question said, if what sine theta is equal to what? Cos theta. Find the value of theta between 0 degrees and 360. Now, at this junction, this is a very tough one, but it's very, very easy. Now, this is what you're going to do. Simply divide both sides by what? Cos theta. So at this junction, cos theta cancel cos theta. If cos theta cancel cos theta, then this is going to give us what? 1. So sine theta over what? Cos theta is equal to 1. Please. Now look at this. This relation, sine theta over cos theta is going to give you tan theta. So it's going to give you tan theta, and sine theta is equal to 1. I believe I've explained this relation, or let me take it briefly. Now, how does what? Sine theta is equal to what? Tan theta, that's your 2, is equal to opposite over what? Adjacent. Now, what is your sine? Your sine is equal to opposite over hypotenuse, and your cos is equal to, what is your cos? Your cos is equal to what? Adjacent over hypotenuse. Now, I just said if I divide sine theta over cos theta, it's going to give me tan. Let's do it. Let's see what's going to happen. So sine theta over what? Cos theta. What is my sine theta? My sine theta is equal to what? Opposite over hypotenuse divided by my cos is what? Adjacent over hypotenuse. So I can further say that opposite over hypotenuse times hypotenuse over adjacent. Here my hypotenuse cancel my hypotenuse, so I have my opposite over adjacent, and that is the same relation for tan. So since this relation is equal to this, therefore sine theta over cos theta can be evaluated to be tan theta. So at this junction, my tan has to come to this side. That becomes theta is equal to tan inverse of 1. So theta is now equal to tan inverse of 1 is 45 degrees, and that's what I have here as my answer. Now, please pay attention to this question. At this point, I have my answer at my first quadrant. But look at what the question said. The question said find theta between 0 degrees and 360. I'm to have two answers here. Now, I told you to find the equivalent of 45 degrees. Now, we are going to open there's this relation I told you to note. Tan theta is equal to theta minus 180. If you remember this relation, I told you to note it. So now, my tan 45, which I'll write it here, my tan theta here, that's what 45 is equal to theta minus 180. So at this junction, 45 this comes over plus what? 180 is equal to what? Theta. So theta here is equal to 225. Therefore, my value of theta between 0 degrees and 360 is theta is equal to 45 degrees, 225. So at this junction, we have that as the final answer. Now, going further, the tangent of 135 has the value of what? And let's review our this. 135, this is what? All. This is sine. This is tan, and this is cos. All. Now, when I say 135, where the 135 for? 90, 180. So 135 fell here. 135 falls in the what? In the second quadrant. Since it falls in the second quadrant, now they ask us to find tan of 135. Since it falls in the second quadrant, then it tells us clearly that our answer is going to be a negative value. Our answer is going to be a negative value. Now remember the relation. I told you a relation. If you are asked to find what tan equivalent, then you're going to have tan theta is equal to what? Theta minus 180. This relation is really, really necessary. Now, they ask you to find the value of what? Tan 135. That is equal to tan, okay, tan this, that is 135 minus 180. So this is now equivalent to what? Tan 135 minus 180, that will give us what? Minus 45. Now that is equal to, this minus comes out, that's minus what? Tan 45. So tan 45 here is going to give us what? 1. So we have what? Minus 1 as our answer, and that is what? A. Now look at this. Without using tables, find the values of sine 120. Now, if we pay attention, 120 falls here, and sine is positive in the second quadrant. So this tells us clearly that what? Our answer is going to be a positive solution. So sine, don't forget the relation. Don't forget the relation that says sine theta is equal to theta, 180 minus your theta. So with this, we can now proceed. I had that what? Sine 120 is equal to sine 180 minus 120. That's going to give us sine 180 minus 120, that's what? 60. And sine 60 degrees, that is equal to root 3 over 2. And that is the what? Our final answer. Identities. Now, identities here, when talking identities under complementary angles, and I told you here that complementary angles are angles which their sum gives what? 90 degrees. Now look at having a right angle, we have what? This side to be what? 90 degrees. And we have what? Two internal angles, which are what? The two internal angles are what? Alpha plus what? Theta. Alpha and plus theta is equal to 90 degrees. So, therefore, alpha and theta are complementary angles. They are complementary angles because their sum gives 90 degrees. So at this junction, alpha is now equal to what? 90 minus theta. So let's proceed. Now sine theta can be given in what? It's equivalent in what? Cos. In cos. So sine theta is going to be equal to cos 90 minus theta. Okay? Cos theta here is going to be equal to sine 90 minus theta, and tan theta here is going to be equal to what? Cot 90 minus theta. So we're going to use this relation and more to solve. Now, talking what about identities, now we have what? Sin squared theta plus cos squared theta is equal to what? 1. Now this is a very, very important relation. So I'd like you to note it. Now from this relation we can get different other relations. Now if we what? Divide through by what? Cos squared theta. Now that is what? Sin squared theta over cos square theta plus cos square theta over cos square theta is equal to 1 over cos square theta. So this cancels out. Sin square theta over cos square theta is going to give us tan square theta. Remember the relation plus 1. So 1 over theta is going to give us what? Sec square theta. This is another what? Relation. And these relations, they are very important. These relations, they are all very, very important. I want to be using them. So let's say, how about we divide what's true? Okay, let's call this equation 1, call this equation 2. So let's divide equation 1 by sine square theta. So that becomes what? Sine square theta over sine square theta plus what? Cos square theta over sine square theta is equal to 1 over sine square theta. So dividing this cancels, then that left with what? 1 plus cos square theta over sine square theta. That's going to give us cot square theta is equal to 1 over sine square. That's going to give us cosec square theta. This is another relation. This is another identity called equation 3. So we can get as much identities, we can interchange them. You can say from here you can say that tan square theta is equal to sec square theta minus 1. This is also another relation. So you can just be changing them through solid or formula depending on what you are given. You can call this what? Equation 4. So you can be what? Interchanging them. They are what? Various what? Identities. So let us use this to solve one or two problems. Now look at this question here. Solution. Question here says sin 90 minus 5 theta is equal to cos 180 minus this. Now recall the relation I gave you. I said that what? Cos theta is equal to sin 90 minus theta. Therefore, if this is here, if I treat this as what? Theta, then cos what? Cos 180 minus what? Theta is equal to sin 90 minus 180 minus what? Theta. Now, with this relation, I cannot use what? This thing to replace what? This. So, therefore, sin 90 minus 5 theta is equal to, instead of writing this now, I'll not use this, because since this is equal to this, I'll not use this. That is what? Sin 90 open bracket 180 minus what? Theta. At this junction, sine can cancel sine. So this becomes what? 90 minus 5 theta is equal to 90 minus what? 180 plus what? Theta. So collecting like terms here, 5 theta is equal to minus 180 plus 90. This comes over to what? Minus what? 90. This theta comes here to be what? Theta comes here to be what? Minus 5 theta minus what? Theta. This becomes minus 6 theta is equal to plus 90 cancel minus 9, that's minus what? 180. So at this junction, what happens? Theta, divide both sides by what? Minus 6 theta is equal to minus what? 180. So divide both sides by what? Minus what? Minus 6. 6 cancels 6. The theta minus cancel minus 6 here or 6 here or 3. That is equal to what? 30 degrees. So the theta here is equal to 30 degrees, and that is your final answer. Now, look at this question. We have here that what? Cos theta is equal to this, and what? I said theta is less than 90 degrees. Evaluate this. First and foremost, having your cos theta here becomes what? Root 3 and what? 2. Let's find the opposite. Let's find the opposite. So what? Hypotenuse square is equal to opposite square plus what? Adjacent square. Your hypotenuse here is what? 2 square is equal to your opposite, you don't know. So your adjacent here is what? Root 3 square. So 2 square here, that's 4, is equal to opposite square plus this cancel this, that's 3. So this is 4 minus 3 is equal to O square. So your O here is equal to square root of what? 1. And your O is equal to square root of 1 is what? 1. Having gotten your opposite as this, now they ask us to find what? Cot 90 minus what? Theta over what? Sine square theta. Remember, I told you that what? Now your cot 90 minus, I explained, I gave you the relation. Cot this is going to give you what? Tan theta over sine square theta. What is your tan? Tan is equal to, what is your tan? Your tan is what? Opposite over, your opposite here is 1. Opposite over adjacent, that's what? Root 3. Divided by, that's this your tan. Divided by sine. Your sine is what? Opposite over hypotenuse, that is what? 1 over 2 square. So at this junction, this is now what? I can rationalize this. This is now what? 1 over what? Root 3 times root 3 over root 3. Please put it in brackets. Then divided by what? 1 over 4. So going further, this is now what? Root 3 over 1 times root 3, that's root 3, right? Root 3 times root 3, that's root 3 squared times 4 over 1. So times the 4 times in that. So that's going to go further. That's going to go further to be root 3 times 4, that is 4 root 3 over, this cancel this, over 3. So therefore, or rather, cot 90 minus theta over sine square theta is equal to 4 root 3 over 3, and that is your final answer. Now, pay attention to this question. Given that sine A plus B is equal to this, let's write that relation. That sine A plus B is equal to sine A cos B plus cos A sine B. Now, would I evaluate? What they ask us to evaluate? They ask us to evaluate sine 105. So your sine 105 now is going to give you, you can break this down to two special angles, which is going to be sine 60 plus 45. So you're not going to what? Split them out in this form, which becomes sine 60 multiplied by cos 45 plus cos 60 multiplied by sine 45. So at this junction, your sine 60 plus 45 becomes, or your sine 60, what is your sine 60? Sine 60 here is going to give you root 3 over 2 according to your special angles. We've done that. Then cos 45, your cos 45 is going to give you root 2 over 2 plus cos 60 is going to give you 1 over 2 multiplied by sine 45 is going to give you root 2 over 2. So in this we multiply root 3 times root 2, that will give you root 6. 2 times 2 will give you what? 4 plus 1 times root 2, that's going to give you what? Root 2 over 2 times 2 will give you what? 4. As usual, you do for your LCM, which is what? 4. 4 divided by 1, 4. 4 times root 6 plus 4 divided by 1, 4. 4 times root 2. And we have this here as our final answer, which is root 6 plus root 2 all over root 4. Now, sine inverse or arc ratios. I have an example here from NECO 2008. He said if sine y is equal to cos 48, find y. If I have to find y here, first and foremost, let's find this. This is sin y is equal to cos 48. You have to use your calculator or your log table, your 4-figure table, or mathematical table. So cos 48 here is going to give you 0.6691. So at this juncture, your sine needs to come to this particular part. So your sine coming over is going to come in as what? Arc sine or sine inverse. So while here, this sine coming over here becomes what? Sine inverse of 0.6691. To get your sine inverse from your calculator, this is how you're going to press shift then sine. When you press shift then sine, it's going to give you what? Sine inverse in your calculator. So the sine inverse here now gives you what? Sine inverse of 0.6691. That's now going to give you what? 42 degrees. So your y here is equal to 42 degrees. Now, if you don't want to use this approach for this particular question, you don't use this approach. Since you are given that sine, y is equal to cos 48. Now, let's express cos in terms of what? Sine. Cos 48 is equal to, remember when I said that cos theta is equal to sine 90 minus theta. So, cos 48 is equal to sine what? 90 minus 48. So at this junction, you can now say what? Sine y is equal to, instead of writing cos now, but you then replace it with sine 90 minus 48. So your sine can now cancel your sine. Y here is equal to 90 minus 48. So your y is equal to 90 minus 48, which is your 42. So if you want to solve with this pattern, you have another pattern ready for you. Just remember your relations correctly. Now, we have another question from Mike here, which says that what? That cos x plus 25 is going to give us what? Sine 45. So this becomes what? Cos, open bracket, x plus 25 is equals to cos sine 45 is going to be root 2 over 2. So this comes over, this x plus 25 is equal to cos inverse of root 2 over 2. So the x plus 25 is equal to cos inverse of root 2 over 2. That's going to give you 45 what? Degrees. So at this junction, x here is equal to 45 minus 25. So x here is equal to 20. And that is your final answer. So, if you are to proceed, now using the relation cos what? X plus what? 25 is equal to what? Sine 45. This is same as cos what? X plus 25 is equal to cos 90 minus 45. So my cos can cancel. So x plus 25 is equal to 90 minus 45. So x plus 25 is equal to 45. S is equal to 45 minus 25. So S is equal to 20. So whichever one still gives you your answer. So the main thing here is what? You understanding your relation correctly. So going further, look at this question. Solve the equation. If 3 sine theta minus 4 cos theta is equal to 0. And theta is what? Acute. So this becomes 3 sine theta is equal to 4 cos theta. Let's divide both sides by 3. So 3 cancel 3. Now this is sine theta here is equal to what? 4 cos theta over 3. Now let's divide both sides by cos theta, cos theta. So cos theta cancel cos theta. Now I'm left with sine theta over cos theta is equal to 4 over 3. Sine theta over cos theta will give us the relation tan theta is equal to 4 over 3. So here, theta is now equal to, my tan comes over to be what? Tan inverse of 4 over 3 Theta is equal to my tan inverse of 4 over 3 is equal to 53.13 degrees. 53.13 degrees. Okay, that is what? A. And that is our final answer. So finally, we now have our exercise here. Number 1 said cos 12 over 13 is this, and we have its answer. So if cos this is this, find this, which is that's the answer. You have to pay attention to the instruction. I said if tan this is tan beta is this, find the summation of what? Tan alpha plus tan beta. This is the solution. Now solve the equation 3 cos theta plus 1 is equal to 0. Now this is the solution. And lastly, the last question, 0 is less than or equal to x, which is less than or equal to 90 degrees. Find the value of alpha in the equation. Okay. Our alpha in the equation, which is what? Sine what? 2 alpha minus 4 is equal to cos 5 alpha plus 3, and its answer is what? 13. So use the relation as we have explained to evaluate the question.